if sum of this series 40C0 plus 41C1 plus 42C2 and so on to 60C20, this is m by n into 60C20, where m and n, these two are co-prime numbers. That means there is no common factor between m and n. The HCF of m and n will be 1. So then we have to find the value of m plus n. I mean, whenever you have one integer divided upon another integer and we have to find m plus n, we need to find unique value of m and n. So then this condition is added that m and n, these two are co-prime number. So therefore there is no common factor between those two. If there is any common factor, you have to cancel that one and write this fraction in a smallest form. So here first we need to simplify this left hand side and then we'll compare with this right hand side and we'll see what should be the value of m and n. Now, before we attempt this problem, there is one important property of binomial coefficient that we must know. The property is that if I have NCR plus NCR plus 1, then this is nothing but n plus 1 CR plus 1. Right? This is one very important result related with binomial coefficients, that NCR plus NCR plus 1. This is n plus 1 CR plus 1. In order to apply this property, you can see that these two must be same, and here there should be difference of 1. If one term is R, other one should be R plus 1. So then we need to add 1 in this one. So this becomes n plus 1 and then CR plus 1. Now, in these type of problem where you have sum of binomial coefficients and this thing is changing C0, then C1, C2 up to C20. So then you can think of this property. See here, 40C0, next term is, let us write the left hand side. Left hand side is 40C0 plus 41C1 plus 42C2. I'll write few more terms. Next will be 43C3. And in this manner, it will continue up to 60C20. Now, in order to apply this property, as I said earlier, that these two numbers must be same, n and n. Right now, one is 40C0, other one is 40. Here we have difference of 1. One is C0, other one is C1. But these two must be same, then only we can apply this property. So for that, we are going to use one interesting trick, that 40C0, this will be same as 41C0. Right, 40C0 or 41C0, those two are same, and their value will be 1. Right, NC0, whatever be the value of n, is always 1. So instead of 40C0, I'm writing 41C0. And now you can combine the first two terms. Right, you can see that if we combine these two terms, then sum of these two terms, one is NCR plus other one is NCR plus 1. So this will become n plus 1 CR plus 1. That means sum of these two, this will be nothing but n plus 1. So from 41 you will get 42 and then C1. Now you can see what will happen if I combine it with the next term. Right, now if I combine the first three terms, sum of first two term is 42C1. Now add 42C1 with the next one. Right, so 42C1 plus 42C2, this will become 43C3. Now add sum of first three term, this is 43C3, C2 in fact. Right, we have to add 1 and then we have to take the bigger number here. So 42C1 plus 42C2, this will be 43C2, and 43C2 added with this next one. Right, now we are going to add the first four terms. Sum of first three term is 43C2. 43C2 plus 43C3, this will become 44C3. Right, so you can see that you can add this term with the next one and you can use this property. So ultimately, when you add all the terms on left hand side, you can see that 43 became 44, C3 is same as C3, 42 became 43. So you can see that if I continue this operation till the last term, then this 60, this will become 61 C20. Right, you can see that this number is not changing. If I add the first four terms, then the result is 44C3. So if I add all of these terms, the result will be 61C20. So that is the sum of left hand side, right? The left hand side will be 61C20, and now on right hand side we have m by n, this multiplied by 60C20, and now we have to use the definition of NCR. So 61C20, this is 61 factorial, and this divided by 61 factorial, and that divided by 20 factorial, multiplied by 60 minus 20, that is 41 factorial. And on right hand side we have m by n, and then this will become 60 factorial divided by 20 factorial into 40 factorial. So from here clearly you can see that m by n, this will become 20 factorial, you can cancel 41 and 40. So you will get 41 factorial in denominator, right? 41 factorial you can write as 41 into 40 factorial. So, and similarly 60 and 61. So you will get 61 there. So that means m by n, this is 61, and that divided by 41. And as you can see that there is no common factor between 61 and 41. In fact, both of them are prime number. So m and n, 61 and 41, these two are co-prime or relatively prime, or their HCF is 1, right? So now the problem was we have to find m plus n. So clearly you can see that m will be 61, right, in smallest form. This is the fraction 61 by 41. Now m is 40, m is 61, n is 41. Sum of these two, this will become 102. So that is the correct answer for this problem, right? So as you can see that this was a very interesting problem. We're using this simple result that NCR plus NCR plus 1, this is n plus 1, CR plus 1. We can combine all the terms on left hand side. The important trick was that in order to start that series, these two must be same. We must have n at these two places. But here in first term we had 40C0 and next one was 41C1. So 40C0, this you can write as 41C0. Now sum of first two, 42C1, added with the next one, 43C2, and so on. So left hand side was 61C20. Now compare with this right hand side. Finally m and n, 61 and 41, their sum will be 102, and therefore that is the correct answer for this problem.